Angle identities. A lot of these are like, prove other things with these, and I'm like, that's just not.
So for the quiz Wednesday, that's like where we can write down all the identities on the sheet and then like give it to you, and then that's like extra credit. Or no, you'll check.
I'm just gonna check it, but yeah, but then you'll also be able to use that for the test.
Okay.
When we get there. So yeah, basically I'm gonna make you prove that you know them on Wednesday, and then for the test I'll just let you have them.
Okay.
All right, write the expression as one involving only sine and cosine. So let's see, we've got sine of 2 theta plus cosine of 2 theta. And I need to rewrite that in terms of sine and cosine. Try to see how far they actually want us to take this, because there's a few different levels of how far we can go, and I don't know how far they want us to get. Okay. How can we rewrite sine of 2 theta?
2 sine theta, cosine theta.
2 sine theta, cosine theta, plus how can I rewrite cosine 2 theta?
There are a lot of ways you can do that.
Do any of them work, or is it like?
It looks like from what they have in the back that they would take any of them. So pick your favorite one, I guess.
2 cosine squared theta minus 1.
Yeah, they evidently don't care about anything that happens after that. Okay, cool. Because I was like, I don't know if they were okay with like the squareds being in there or not, but apparently they are. Because it says in terms of sine and cosine, so I'm like, that could mean that they're against that, but I don't know.
Well, isn't the starting thing already in terms of sine and cosine, technically? Also quite literally.
Yeah, but they don't want them written as double angles.
So this is just where we stop at.
Like it has to be like sine theta, cosine theta, not, yeah, you just stop
They
there.
just little-
That's why I'm saying this book does not do a good job with this stuff. Like in terms of like what they actually could do.
Yeah, they're just being picky.
Yeah, I'm like, no. Let me see. This looks like something that you might actually would need for the AP exam, so let me see if this is what I think it is. Okay, let's try these ones. Okay, these ones say to solve algebraically for exact solutions in the interval from 0 to 2 pi. So they want like however many values make this true. That's what we're using. So 24, cosine of 2x plus sine of x is equal to 0. And they want us to solve for x, basically. So I need to rewrite cosine of 2x first. So how would I do that?
I don't know, I think we might want to make them all sine.
That would probably be a good idea.
Yeah,
I
so
would
I
say
think-
try to make them in terms of something we already have. So sine would probably be a smart option. So what would that one be?
1 minus 2 sine squared of x plus the,
Now, this might be a good time to rewrite this in the order so that we end up with something that looks like this, right? Okay, obviously the signs are going to be different, but something that looks like that. So I would say do -2 sine squared x plus sine of x plus 1 equals 0. So if you need to, we can do u substitution and try that. So let u equal sine of x. So we would have -2 u squared plus u plus 1. So I need factors of -2 that add up to 1.
-1 and +2.
-1 and +2. So -2u squared plus 2u minus u plus 1. Take out a, I'm going to take out a negative. -2u, which leaves me with u plus minus 1. Then take out a -1, leaves me with u minus 1. So I have -2u minus 1 times u minus 1 equals 0. Now we would need to plug back in. So we would have -2 sine of x minus 1 times sine of x minus 1. And then we're going to split it and solve. So we would have -2 sine x minus 1 equals 0 and sine of x minus 1 equals 0. So then the left one, sine of x, would be equal to -1/2. And this one over here, sine of x, would be equal to 1. We're on the right track here. Yes, we are. Making sure we're going to get to the same answer that they got to. Okay, so then I need to know what angle values from 0 to 2 pi give me the sine of x is equal to -1/2 and sine of x is equal to 1. So let's start with sine of x equal to 1 because that's easy.
So do we
Where
want
is
to
sine
use
equal to
radians?
+1? Yes, in radians.
Pi over 2.
Pi over 2. Where is sine of x equal to -1/2?
Sign's on this side, right? Or does that not matter in this case?
So in this case, it doesn't matter when we're solving equations. That does matter when we're doing inverse trig functions, but technically we're just finding the angles that give that value.
2 pi over 3 for the sine of x.
Sine's got to be -1/2. So I don't know where my unit circle went. Oh, it's on the floor.
7 pi over 6.
Yep. And
11 pi over 6.
yep.
I'm thinking cosine of that.
Okay, 7 pi over 6 and 11 pi over 6 would be where that happens. So all three of these would be your solutions to this problem. Honestly, problems like this is more where I see them actually asking you to use double angles for things for solving, is to rewrite things and solve like this. More how I visualize that they're going to do it, but could be wrong. Use half-angle identities to find an exact value without a calculator. So this is, again, more of what I would expect to see for half angles. These are actually solving them, which you'll remember we did quite a few of these last year. So 32 is the tangent of 195 degrees. So a couple things to remember. We're looking at if it's positive or negative with sine and cosine based off where the original angle is. Okay. Let me verify that on the. I'll have it written on that paper. So let me just check and make sure. Yeah, it's the quadrant that the original angle is in. For that particular thing, so like if cosine is in quadrant 2, it's going to be negative. The negative formula is what we're choosing. So tangent doesn't matter, obviously, but just wanted to throw that out there real fast. So I need to figure out this is half of what angle?
390? No, I can't count. I don't think.
No, I think that would have been it.
Oh. It is.
Yeah.
Okay, so this would be half of 390. So the way you can look at this is like if u over 2 is equal to 195, then u would have to be equal to 390. But what's the problem with that? Is that on the unit circle?
No.
So what might I need to do? Find a coterminal angle. So the coterminal angle, we would subtract 360 and get 30. So now, the tangent of 30 I feel like that's not how I wrote those last year.
I guess it is.
All right, so formula for tangent would be what? And if there's multiple options for any of them, you can just pick whichever one's your favorite.
Sine of theta over 1 plus cosine of theta.
So sine of 30 over 1 plus cosine 30. So what is the sine of 30?
One half.
Dang it.
What were you going to say, Riley?
Not the right one.
Oh.
Over 1 plus, what's the cosine of 30?
Square root 3 over 2.
Square root of 3 over 2. So then I can rewrite this 1 as 2 over 2. I'm just going to do it this way. Just so that I don't have to. So this is going to be 1/2 over 2 plus root 3 over 2. Now what?
Keep change foot.
So 1/2 times 2 over 2 plus root 3, which gives me 1 over 2 plus root 3. Am I done?
Nope.
What do I need to do?
There be no
The
thing on
conjugate thing.
Conjugate.
That.
2 minus root 3, top and bottom. So that's going to give me 2 minus root 3 on the top over 4 minus 3 on the bottom. So that's just 2 minus root 3. And remember, just like sum and difference formulas, your answers for these ones should all kind of look the same. Like tangent answers should all kind of look like this. Sine and cosine answers will all kind of look the same way as well. Um, 34. Sine of 5 pi over 12. So with this one, we need to Well, there's a couple different ways we can do this. You can do it by leaving it in radians if you were so inclined. I can show you how to do that. But what I would have told you last year is change this to degrees and then use degrees to do it. But I am going to show you with radians just on the chance that that's how it would be set up on the AP exam. It's actually really easy. We let u over 2 be equal to 5 pi over 12. And then we solve for u. So u would be equal to 2 times 5 pi over 12, which would be 5 pi over 6. So I just multiplied by 2 here. And then the 2 and the 12 reduced to 5 pi over 6. Now, is this going to be a positive or a negative one? The original angle. Positive, okay? The sign would be positive up top, which is where this is. So this is going to be when I use my formula, this is going to be equal to the positive one. Now, I'm not going to write the positive every single time down. If it's negative, obviously you need to write it all the way down. But I'm going to write the positive just the one time, just so I can see like that I was intentional about choosing it, and which one it was. So the sine of 5 pi over 6. So formula for this one would be what?
The square root of 1 minus cosine theta over 2.
Yep. So like that. What's the cosine of 5 pi over 6? Yep. So this is going to be the square root of 1 plus square root of 3 over 2 now because of that. I'm going to go ahead and rewrite this 1 as 2 over 2 just so I can get a common denominator. Then all over 2. So this would be the square root of 2 plus root 3 over 2. Would you agree that dividing by 2 is the same as multiplying by 1/2?
Yeah.
So I'm going to multiply by 1/2 here to make my life easier. So now on top, I'm going to have the square root of 2 plus root 3 over on the bottom. Remember, when I have a square root on top and bottom, I can split it up and do the square root on the top and the square root at the bottom. So over the square root of 4, which is going to give me a final answer of square root of 2 plus root 3 over 2. So I'm just going to tell you the way that the book will write their answers is they write it as 1/2 times the square root of 2 plus root 3, like that. So more just for reference for you, that if you see it written like that, that's why. Let's see, cosine of pi over 8. This will be our last one. So cosine of pi over 8. So I can let u over 2 equal pi over 8. Then when I multiply by 2, u would be equal to pi over 4. Is this one going to be positive or negative?
Positive.
Positive. So the cosine of pi over 4 is positive. Square root, what's the formula for cosine?
One plus cosine of beta over 2.
So 1 plus cosine of pi over 4 over 2. What is the cosine of pi over 4? Root 2 over 2. So again, I'm going to rewrite 1 as 2 over 2 plus root 2 over 2 all over 2. It's a lot of 2's. So this is going to be the square root of 2 plus root 2 over 2 times 1/2. So this is going to be on top the square root of 2 plus root 2 over the square root of 4, which would be 2. So just to save writing, I'm just going to skip that little intermediate there. That looks like all of it. This problem is weird. So I give this multiple choice question, and I swear these two answers are exactly the same. I don't understand. Okay. All right, problems for you. Let's see. Where did we even start? I don't even know because I did a couple other things. 12. Okay. 11. Let's see. We didn't do any of those ones. 23. And then 31, 33, and 35, because that'll give you one of each of the trig functions there. If you want to see what a multiple choice question of this would look like, 50 would be one you could try for that. I swear answer option D and E are exactly the same. And I don't know why. Maybe I'm just like going crazy looking at it, and maybe it's a typo in my book that's not in your book. I don't know. I'm assuming one of them is supposed to be plus and one of them is supposed to be minus, but they literally both say the square root of 2 minus the square root of 2 over 2. So.
Yeah, you're right.
Confirm.
Okay. Well, if the answer is supposed to be one of those ones, and like let's say it's supposed to be plus and one of them's not, just put your final answer down there when you do that one and see. Cause I was like, I don't know why. There's got to be a typo there.